Yeah, we finished until this part. We learn about tail recursion. What is tail recursion? The tail recursion occurs when a linearly recursive method makes its recursive call as its last step. So the keyword is this last step. Whenever we have the whenever we have the recursive method at the last step, then we call this is tail. One of the example is the reversal method. And some methods can be easily converted to non-recursive method. So if you want to make a function, let's say this one, the iterative reverse array, yeah, we can do something like this. So we don't need to do with the recursive, we can just do with the loop. So we swap and then we add I by 1 and then we decrease j by 1. We can do this one to do the reverse. We have another kind of recursion, we call it binary. We know binary means we have two. We have two branches. So the binary recursion occurs whenever there are two recursive calls. And this is for its non-base case. For example, we have the binary sum. The binary sum means I want to add all the numbers in an integer array. So I have this list. This is index 0, index 1, index 2, index 3, 4, 5, 6, 7, 8, and then this is the element. So I want to add those numbers. 2 plus 4 plus 5 plus 7 plus 8 plus 9, 12, 14, 17. I can do with the binary sum. So this binary sum, I want to use the array A, and then I want to use I as the position or the starting index, and then n is the number of integers that I want to sum. So the output will be the sum of n integers in A starting at index I. So if n equals to 1, it means if we have only one remaining value, then we will just return AI. Otherwise, we will do the binary sum A, comma I, starting from the index I, until n divided by 2. It means if we have 8 numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, let's say this is 9, okay, from index 0 until 8, we can split into 2. This will be the value of this one, and the remaining will be this one. And then we will split again to half of the numbers. So it means we will split this one and this one. For the right side, we will split this one and this one until the lowest one, and then we can do the summation. We can do the summation, and then we will sum all the numbers in this array. Because we have two, okay, this is two recursive calls. We call this is the binary recursion methods. The first call is for the left side, and the second call is for the right side. So the beginning of the index is I, but the beginning of this index is I plus n divided by 2. The ending of this binary sum will be n divided by 2. This will be also n divided by 2. So I want to start, let's say, I want to start from the index 4. Then I would like to add, or I want to sum until 4 items. So it means I will sum the next 4. Okay, so this is the binary recursion because we have 2 recursive calls. Oh, okay, I show you this one. So we can split, and then we can split again, and then we can do the summation. So if you want to look at the details, I give you this code. So you can look at the this is another example. So this is another example for the binary sum. We call this is list sum. So there are 51 steps. So you can look at the step by step. For every step, then you will see how they go to the left one, and then after they finish with the left one, how they go to the right one, and so on until they got the summation. Fibonacci. Do you know Fibonacci numbers? So this is a very famous numbers, and usually we try to solve this problem with the computer programming. Okay. We have the numbers start with 0 and 1, and then for the next number, let's say I, it is the addition of I minus 1 plus I minus 2. So if I have 0 and 1, and this is in the position index 0, and then this is the index 1, so the index 2 will be the addition of index 0 plus index 1. So index 3 will be the index 1 plus index 2. The index 4 will be the index 2 plus index 3. The index 5 will be index 4 plus index 3 index 4, and so on. Okay. So we can use the recursive call. We can use the common recursive call with the single call, or we can also use with the binary recursive call. But there will be an issue. Okay, there will be an issue with the binary. Let's see. We can have a parameter k. It is non-negative, because if you put negative, it will not work. So it is non-negative integer, or we call it positive integer, and then the output will be the Fibonacci number fk. K is the number of the Fibonacci number that you predefine. If k equals to 1, then just return k. If not, then I will do the binary Fibonacci k minus 1 plus I will do the binary Fibonacci k minus 2. So we will do the addition first for the k minus 1. Let's say I want to know this number. So I will do the summation for this number, and then I will do the summation for this number. So I want to get what is this number. I want to get what is this number to know what is this number. And I know that this number, the index 2, will be the addition of 0 and 1. And for the index 1 will be just from the initial value. So let's say if I want to know this value, index 5, then it will be the index 3 plus index 4. Index 3 will be the addition of 1 plus 2. The index 4 will be the addition of index 2 and 3. So we want to split into 2. We want to get the addition of the index 3. We want to get the addition of index 4. But when we do like this one, when we do with the binary recursive call for the Fibonacci, we have like this kind of analysis. If the n0 is 1, let nk be the number of the recursive call. If n0 or k equals to 0, there will be only 1. If n equals to 1, then there will be only 1. Okay. So k, if it is 0, yeah, we have only 0. If k equals to 1, then there will be only 1. But what about if n equals to 2? So if I want to show two numbers, then the number of operation will be n1 plus n0 plus 1. So there will be one operation plus another operation, which is 1. So the operation will be 3 operations. When we have n3, so it will be the n2 plus n1 plus 1 operation. So n2 means this one. So there will be 3 operation plus 1 plus 1. So there will be 5 operation. If it is n4, so when k equals to 4, then you can also use like this operation summation. There will be 9 operation and so on. So if we do with the k equals to 8, then the number of operation will increase significantly. Note that nk at least doubles every other time. So I can say at least because it is not double exactly. Let's say 3 to 5. It is almost double. 5 to 9. It is almost double. 9 to 15. It is almost double. So yeah, you can see that then the problem will be something like this. Nk will be 2 power of k divided by 2. It is exponential. So with the binary Fibonacci, it is very high competition. So we cannot recommend with the binary Fibonacci. So using the binary recursion does not guarantee to get a better function. So whenever you do with your algorithm, sometimes it will the recursion may give you a better result, but it does not guarantee to get a better result. We can make a linear Fibonacci, just linear, because yeah, it will give you a better solution maybe. So using the linear recursion, we have linear Fibonacci, and then we have k. This is also the same, the non-negative integer k. So we can look at the result. It is a pair of Fibonacci numbers. If k is 1, then return k, 0. If no, then I would like to know two numbers, I, j, and it will be the linear Fibonacci k minus 1. So I will call again the function linear Fibonacci, and it will return multiple values. Okay, so it will always return multiple values. In this case, we will not need to have exponential problem like the previous one, but we just have the linear. The linear calls, yeah, it will take k minus 1 recursive calls. K is a non-negative integer, or the number that you want to set for the Fibonacci. It means it will be just ON, or linear time. So you can try if you want to visualize this one. So you can use this one. Yeah, you can look at the step by step and then how many operations that it will take for this Fibonacci. For 6, so we will do 6, 5, 4, 3, 2, 1. So it is n time, and after it finishes, then yeah, it will just show for every return value. So it will take n times only. Even though the number of steps is 31, but you need to follow when it enters the function or when it enters the recursion. So we learned about the recursion, some basic definition, and we learned about the linear recursion and some variants. So it is important to understand the difference between recursion and iteration. What you already learned on the computer programming, we know about the for loop, we know about while. So it is the concept of iteration. But we can also use recursion. Why? Why do we need to use recursion? First, it is elegance. Elegance means it is easy to understand the code. So later on, some of the code will require to use recursion. The performance. Some problems can be solved efficiently using recursion, and others not. So the binary Fibonacci, what you saw before, it is not good. But with the linear Fibonacci, you can have the linear solution, or ON. And some other things, you can also use the recursion and the performance might be better. Debuggability. So some problems in recursion are difficult to debug when it occurs. Yeah, this is another issue. So if you work on the algorithms, you need to know how to debug. Debug means you know what is the problem in every line. So step by step, you will look at the lines and then you can figure out the problems. The recursion has an issue with the debuggability. if you use the iteration, it will be easier to debug. I give you some code. So if you go to the materials, the recursion, so I give you some codes. Okay, for the factorial, I guess you already know. For the binary search, yeah, I think I have the problem last time. Okay, I found the problem. I think last time I have the issue with this code, so it does not give you the solution. So the return none is the problem. So you can just remove the return none. Okay. So let's see. So this binary search is using the iteration. So I want to compare the iteration and with the recursion. When you remove the return none, let's say I want to do the binary search to find where is the number 3. I want to find where is the number 3 from my list. We know that number 3 is in this location. So this location is in index 1. Okay. So when you do with the binary search, then you will get the result 1. It means I know that the number 3 is in the index number 1. So I give you another solution with this binary search. For this binary search, we are going to use the recursion. We use the recursion. When we use the recursion, the idea is similar with the loop, but we try to use the recursion to access the function again. So we do not use any while loop at this code. We just use the recursion to call the existing function. Okay, last time we already learned about this. And then I also give you the reverse. So the reverse means we want to do the reverse from the data. Let's say I have this data. Okay. 2, 4, 5, 7, 8, 9, 12, 14, and so on. So I want to reverse. So the one that I want to reverse is from the 0 until the last one, which is 16. So I want to reserve, and then I can look at the data. Now the data will be reverse. So reverse means the original sequence is 2, 4, 5, 7, 8 until 37. But after we reverse it, we got the numbers from the last item. 37, 33, 28, 37, and so on. Exponent, I guess you already know also. Using the mathematical function power. Okay. So it is the same with 3 exponent 3. Okay. So this is the built-in function in the Python. But you can make your own function like this one. So we learn from our PowerPoint materials. So if you make this function, so the it is clear last time that it is more efficient because we try to halving. We try to make it half than the AND operation. Yeah, if you want to check, so I give you the code like this one. If you want to check the power, so this is the power with halving. This is the power with halving. You can check if it is 1000. Okay, 2 power 1000. Okay, it is still 0. If you want to add, oh, it's too large. Okay, yeah, because if you power 3, power 20, then yeah, this is the result. If 2 power 1000, I think the result is too big. In order to solve this one, it just take like 0 second. If you use this one, so I can try with the power slope. So with the same comment, with the same function, the power, when I want to do the 2 exponent 1000, it is 0 second. With the power slow means I'm just using one recursion. So I did not do the halving. I didn't do the halving. So when I do the same problem, it will take 0.0009. So it shows some numbers. It means if you put a bigger number, then it will be higher, higher, and higher. But this one still in the time of Q. So it is still better. Okay. Yeah, when you do your team project, okay, please remember you need to figure out this time problem. I also give you the binary sum. Okay. How you can handle the binary sum. Let's say I have this data and then I have this binary sum. So you can do the summation with this binary sum function. So this is the binary recursion. There is another version of the binary sum. This is the second version. This is the version that you saw in the PowerPoint. So if n equals to 1, then you return the AI. But if it is not, you will do the binary sum. So basically, these two are the same. If the start is higher than equal to stop, then return 0. Else if start equals to stop minus 1, then S start. So it will be from the starting point. And then the middle will be divided by 2, start plus stop divided by 2. And we can do the binary sum for the left part, and we can do the binary sum for the right part. So the idea is the same, but the code is different. And I also give you the code for the bad Fibonacci. I call it bad Fibonacci. It is the binary Fibonacci. Okay. Why it is bad? Because it took a long time. So the performance will be 2k divided by 2, or it is exponential. For the good Fibonacci, the performance will be n times. So you can take a look on this code. And I also give you some code, so you may have some understanding how to do the team project. Okay. For example, inventory. So this is an example how we can use recursion. We define the function calculate inventory value. So the function will be called at the end. So I can call this is the till recursion. Why? Why it is till? Because we call the recursive method at the end, at the last step. So let's say I have this item. Okay, I hope that you can understand this one. So I have 10 items. I have 20 items. What does it mean by this? So usually if you are in the inventory, you have a pallet. In one pallet, there will be maybe some box. So in this pallet, there will be 1, 2, 3, 4. So there are 4 boxes. And inside of this pallet, because we have 4 boxes, and in this box, there are 3 items and there are 7 items. So there are 3 items like this one, and there are another 7 items. So we want to check how many items the small item inside. So in this case, yeah, we have 10, we have 20, and then in this pallet we have 5 for the first box, we have 15 in the second box, and then in the third box we have 3 and 7, and in the fourth we have 10, and then in the other part we have 8. So how can we calculate this inventory? I give you the example. So if it is the instance of the item, then you can add the value. We can use this recursion to calculate how many items in the inventory. So you can also develop the same thing with the recursion. The other example that I want to show is this one. So I want to show this one because I think you need more ideas to do the team project. I give you the code calculate total cost. So let's suppose this is kind of logistic. So in the logistics, you have factory, you have warehouse, and you have the retail store. So I want to set up my factory, and I want to know, is it possible to go directly to the warehouse, or I can go to the retail house through the warehouse, or what is the best trip, or what is the best transportation? If I go from the factory to the warehouse, it will cost 10. If I go from the factory to the retail house, it will cost 20. If I go from the warehouse to the retail house, it will cost 5. And then what I want to deliver is from the factory, I would like to deliver 100 items. From the factory to warehouse, I will deliver 100 items. From the retailers to from the factory to retail store, I want to deliver 200 items. From the warehouse, I want to deliver 150 items. So with this kind of product, what is the best transportation? Are we going to do the transportation from factory to retail? And then there will be another truck from warehouse to retail? Or should I go from factory to warehouse and then go to retail? So this is just one solution. Okay. I want to calculate the total cost and which the proper transportation. Yeah, you can think any other idea for your team project. This might be one of the idea. And you know that this kind of cost you can generate by yourself. You can just ini London itu. Okay. So you can just think, maybe you can check from the neighbor or you can do by yourself. It's okay. Okay. So I will go to the next chapter, which is about array. In Python, there is a class about sequence. We know about the list in Python. Actually, in Python, we also can use array. So the sequence classes in Python, as you might know, we have list, we have tuple, we have string. Each of these sequence types supports indexing to access the individual element of a sequence. So for example, if I have the array A, and then I want to access the index 0, then I can use the square bracket to access the data. Each of these type use an array. So when you use list, actually you are using array. When you use tuple, actually you are using array. When you use str, actually you are also using array. An array is a set of memory location that can be addressed using consecutive indexes, which in Python start with index 0. Okay. So if I have this sequence, this is index 0, index 1, index 2, index 3, and so on. Some other programming language, they may start from 1. Okay. But Python start from 0. Java start from 0. C Sharp start from 0. As far as I know, there is one programming language. If you use R, the array start from 1. So there might be some other programming language when the array also start from 1. So you need to look at the details of that programming language before using it. So when we use the array, we can also think that this array is array of characters, or it can be also an object of reference. An array can store primitive elements. So primitive elements, it means you can have one character, like this one. Or another primitive element is number. So let's say I have 0, 2, 4, 6, 8 like this. So this is primitive element. We can just say that it is a compact array. Every element have one single data, or every element just have a primitive element. But an array can also store reference to objects. So if I want to access the index 0, it is about the data of this person. If I access the index 1, then this is the data about this person. If I access the index 3, then it is the data about Jonas. So it can be a reference to objects. In Python, the primary support for compact array is a module named array. I'm not sure if you work with array before in Python. Usually we just use list. It's easy. But you need to know another type of data structure, which is array in Python. When you do the data analysis, or when you try to develop some algorithms with deep learning, you may use this kind of array. So that module defines a class, also named array, providing compact storage for arrays of primitive data type. The primitive data type, we know the primitive data type, there are 3. What are they? There are 3. The first is integer. Second is float. And then we have string. Okay, so those 3 are the primitive data types in Python. Later on, you can see the integer will be integer 32 or integer 64. So it is only the variant. So the constructor for the array class require a type code as a first parameter. So like this one, I, it is the parameter, which is a character that decides the type of the data that will be stored in the array. So if I define I, it means I want to put integer value. So every of this element will be integer. If you define this one as f float, then you will have all the elements as a float number. Okay, let me just show you with this example. So we need to import the array. And after we import the array, we can make an array with a definition of the parameter. So D is another parameter. If you see this one, D is a float. Okay. So I can make a float 1.1, 3.5, 4.5, and then this is an array. We call this is compact array because it is just a primitive elements that we are going to use. Okay, let's stop here. Let's have a break. I'll continue after the break.